girls lie. Let's all take one deep dive into the world of science, technology, engineering, and math. Get your safety goggles, 'cause we're making things explode. Science is so fun, so let's take it on the road. Meet a young scientist just like you and learn all about what they do. We'll even learn science that's in the news through one-on-one interviews with SCFGLive and friends. Experimenting never ends. Now let's see what's in store. Just press play and get ready to explore. Ho, 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 hey, hey, ho, ho, ho.
Hey, young scientists, welcome back to another episode of SCFGLive. Hey, Anna, it's so nice to see you today.
It's so great to see you too. Are you excited for today's episode?
I am so excited. What about you?
Me too, but I'm honestly a little scared about today's episode.
Why?
Well, today we're going to be talking about a topic that I think is a little scary. Because today we're talking about blood.
Ooh, blood. Yeah, it can be a little bit scary, but blood is really important to how we survive as humans. Today we're going to take a closer look at what blood is made of and what it can do for us as humans to survive. Hopefully by the end of the episode you won't be as scared.
Well, I hope you're right. And it does sound good to take a closer look at blood because I've always wanted to know more.
Yep, by the end of today, we're going to be experts.
Cool. Well, let's get started.
Woo! Today's word of the day is blood. Eek, blood. Don't be scared. Blood is a very important part of keeping us alive. Blood is the red fluid that circulates in our body's circulatory system and brings nourishment and oxygen to all the parts of the body and carries away waste from all the parts of the body. How does it do this? Let's talk about the pathway it takes and some of the components that help blood do it. The blood needs a map to get to different parts of the body, and that's what we like to call the circulatory system. The circulatory system is a system of blood vessels that carry blood away from and towards the heart. The heart is like the main organ in charge of this movement. The heart pumps blood through the blood vessels to get the blood to where it needs to go. First, the heart pumps blood with nutrients and oxygen in it away from it to deliver it to the whole body. When the blood drops off the nutrients and oxygen where it needs to go, the blood comes back toward the heart and lungs to replenish or fill up with nutrients and oxygen again. The blood vessels that carry the oxygenated blood, which is the blood with the oxygen in it, are called arteries. And the blood vessels that carry the deoxygenated blood, or blood with no oxygen back towards the heart, are called veins. Think about it like this. The circulatory system is like the roads in a city. All the roads are connected and lead us to different places. We could take paths to deliver food to ourselves, just like arteries deliver nutrients and oxygen. We can also take paths in the city to get rid of our garbage and recycling, just like veins do with deoxygenated blood. Now that we understand the map of blood, let's take a closer look at the different parts that make up the blood in this Try It Out section.
When you get a paper cut or a nosebleed, what does your blood look like? It probably looks like a super dark red, right? But if you were to look at blood really close, like with a microscope, it actually looks completely different. It is made up of 4 different parts that are all so important to how our blood functions. Let's talk about what these 4 parts are. First, there's plasma. Plasma is the liquid part of blood. It's thick, yellowish liquid, and it makes up over half of your blood, about 55%. Plasma is able to transport nutrients that our body needs. It's also able to take away any waste or garbage that our body parts don't need anymore. Second, there are red blood cells. These are the one solid pieces of blood, and they make up just about half of your blood, about 45%. Just like how plasma carries around nutrients to our body parts, red blood cells carry around oxygen. Up third, we have white blood cells. Even though each cell is a bit bigger than the red blood cells, altogether there are not many white blood cells within our blood, less than 1%. Still, they have the super important job of attacking germs and fighting diseases. Last but not least, we have platelets. Platelets are extremely tiny. They're actually little pieces of other cells. If you had a bloody nose, it doesn't bleed forever, right? That's thanks to platelets. They help to clot blood. Clotting is when our blood transforms from a liquid to a solid. When it's solid, it will stop dripping from your nose. So remember that some of these parts are liquid and some of these parts are solid. In this activity, we're going to be able to make a model of all 4 of the blood components. And instead of using a microscope, we're going to use everyday kitchen items so we can actually see what's going on. You'll just need a few simple supplies. You can use corn syrup or a vegetable oil, red candies like Red Hots or M&Ms or Skittles or these gumdrops, marshmallows, sprinkles or small tiny dots, a small bowl or a jar, a spoon, and red or blue food coloring if you would like. So we mentioned that each of these 4 parts of the blood have different amounts. So we're gonna start adding them into our jar here. So first you're gonna start off with the plasma and this liquid part. I'm using vegetable oil today. Remember, it makes up over half of the blood. So we're gonna add quite a lot. Next, you're gonna add the red candies, which represent our red blood cells. Remember, red blood cells don't make up as much of the blood as plasma does. So you're not gonna add as much candies as you did plasma. Remember, this is the part of the blood that brings oxygen to all the body parts. Now we're gonna add our marshmallows, which represent our white blood cells. Remember, these make up a very tiny part of our blood, so don't add a lot of them, but they're still very important, remember, for fighting germs. Right, last we're gonna put our platelets. And remember, these are very important for clotting our blood, so that turns it from a liquid to a solid. And remember, we're not gonna add a lot of these, just a sprinkle. So now you're gonna mix everything with a spoon. If you would like, you could also add a couple drops of red food coloring and some blue food coloring to get that dark red that we see in blood. As you're mixing, notice that the candies and all the different components of the blood move around with the plasma. This is just like how the plasma moves around our red blood cells throughout the body to get it to where it needs to be. Now you got your blood model, and you didn't even need a microscope. Good job, scientists.
Our blood is made up of 4 different parts: red blood cells, white blood cells, plasma, and platelets. These 4 parts are super important because they contain things like nutrients and oxygen that our cells need to work properly. But how does this nutrient and oxygen-carrying blood get to parts of our body that are really far away, like our brain and our teeny tiny pinky toe? It's time to explore the circulatory system.
To set up, me and Hannah drew out an outline of a person so that we knew where we were going to put our arteries and our veins. Next, we covered up our table in plastic wrap so that we didn't get any of it wet, because this was kind of a messy process. We also started getting ready by laying out our tubing to see where it goes and measuring it out.
Here are the materials that we use to set up our circulatory system. We used a plastic bottle, duct tape, water, food coloring to make it look like blood, tubing, and some balloons.
Our model, the water bottle, represents the pump or the heart. These tubes represent the arteries. Arteries carry blood from the heart and the lungs to the parts of our body. You can remember arteries because arteries away from the heart. The tubes that we use for the arteries are bigger and thicker because they have to withstand the pressure of the beating heart. These tubes represent the veins. The veins carry blood from our cells back to our hearts and our lungs. These tubes are thinner and smaller. need to withstand the pressure of the beating heart like the arteries do. The water bottle is our pump. Watch what happens when I squeeze the water bottle. What do you notice? How far does the water make it around our circulatory system with one pump? Could there be a way to make this stronger? Is it able to reach the faraway parts in our body? How could we improve our circulatory system? If we wanted to improve our model, we might want to think about adding some valves in front of our heart pump. Another limitation you might have noticed is that when we pump blood from our heart, it tends to go out and then come right back in. In our real circulatory system, this would be pretty bad if this happened, because we want blood carrying oxygen and nutrients to go out to the parts of our body and then come back carrying bad stuff that we don't really need. So in our real hearts, in our real circulatory systems, there are 4 one-way valves that open and close, preventing blood from flowing right back in. Try building your own circulatory system at home. What other materials could you use? Maybe rubber bands or straws? Try it out!
The heart is a pretty amazing muscle. It's really strong for its size. In our last activity, we got to see all the places blood has to go to keep us alive. Now we're going to see how much blood has to go through our system every day. Our heart pumps around 2,000 gallons of blood every day. That sounds like a lot, so let's break it down even further. Every minute, it pumps about 1.3 gallons of water. That's like 20 cups of water. Yeah, you heard me right, 20 cups of water. So let's break it down even further. Every heartbeat that we have in a minute is about 25 to 85 milligrams. It's about like this 1/3 cup over here. Now, this is all just numbers, so we're gonna do an experiment to see if we can be like the heart and do its job. So in this activity, to be the heart, we're gonna try to move 1.3 gallons of blood from one container to the other in just 1 minute using this 1/3 cup, which is like about the amount of blood pumped in one heartbeat. What you're gonna need for this activity is 2 containers, about 1.3 gallons of water. We did some food coloring to make it look like blood, and this 1/3 cup and a timer for 1 minute. Just remember, this experiment can get pretty messy, so you're either gonna wanna do it outside or near a bathtub where it's easy cleanup. Ready, steady, go. As you can see, I wasn't even close to what the heart can do in a minute, and now I'm just all wet. Now we know how amazing the heart is and how strong of a muscle it is to pump all this water or all this blood from our heart to the rest of our body. All right, have a good day, scientists.
Hi, my name is Siobhan Ford. I currently work in the Rare Disease Unit at Pfizer, and I work as a research technician.
Can you tell us a little bit more what a research technician is?
A research technician does a lot of the testing of blood samples and tissue samples to help with curing diseases.
In today's episode, we talked all about blood. We talked about the components of blood and how blood circulates through our body. And I'm curious how blood relates to your work.
A lot of the times when we try new medications, they have to be given through the bloodstream. And I work in the Rare Disease Unit where it affects the brain, so only some medications get to the brain from the blood. So we like to see how much we test to see which medications can work.
Why do medications have to go through the bloodstream?
The blood will go everywhere in the body. It goes through all the tissues, and it helps to keep the tissues healthy and lubricated, so that everyone can have free movement and can be healthy and awake.
And what is the best part of your job?
The best part of my job is working with the research team and seeing the results of all of our work and seeing people get healthier. We'd like to take in videos of people who have taken our treatments, and you can see them getting better, and that makes us feel really great about what we do.
Amazing. And what's the most challenging part of your job?
I would say it's pinpointing which medications work. It takes a lot of going through them to make sure that everything's safe to use and effective.
And if you had one piece of advice for people who are watching,
to stick with it, even if there's a part you don't like so much, stick with it, learn it the best you can, because once you move above it, you don't have to do it as much, but you see why it's important. And that's the best part about science. You'll always like to know as much as you can, and to learn what will be important later.
amazing.
It was great talking to you. Thank you. Have a good day.
Whoa, we had an action-packed episode. I bet if a vampire saw this episode, she would be so excited about how much we talked about blood.
That's so true. It was really neat that we got to create our own model of blood, and we even got to build our own circulatory system. A whole circulatory system model.
The whole thing.
Yeah.
And I try to race the heart, but we know that the heart is too fast and too good. I can't even beat it.
But you know what, Francesca? You really put your whole heart into it.
All right, everybody, young scientists, see you next time on SCFGLive.
Bye, everyone.
Bye.
This episode is brought to you by Pfizer, who is proud to support Science Club for Girls as part of its commitment to equity and to inspiring the next generation of women scientists and researchers. Pfizer, breakthroughs that change patients' lives. Science Club for Girls is a nonprofit organization that fosters excitement, confidence, and literacy in STEM for girls and young women from underrepresented communities with free experiential community-based programs. To help keep our programs free, please consider making a donation today. Learn more and donate at scienceclubforgirls.org.